Okay, so hi everyone, and as mentioned, I'm Krystal, and I'm a front-end developer at Oberlo, a Shopify company. And during the last almost 10 years now, I've been working in a wide range of projects from websites, mobile apps and games, and even virtual reality projects. Last year, when I started working with Vue, I found it pretty interesting how easily you can create animations and interactions with it. So today I put together a couple of examples and some techniques that you can apply in your own projects afterwards. So before we start digging into these real-world examples, I would like just to show you this little game. So there's this really nice course by a guy called Maximilian Schwarzmüller, and in one of the examples that he does in his course, that you can find on Udemy on this link, Vue.js to the complete guide, he created this game, which is basically a couple of buttons that play around with some variables that have a life bar for you and a monster. And when I saw this, I thought, that's actually really cool. Maybe I could make an exercise to see how farther I could push this interface to make it look like an actual game. So this is what I managed to implement in the end. And I'm not going to talk too much about the game logic here because the focus is on the animations, but the code for it is on my GitHub, so if you're interested, you can just download the repo and play around with it. So let's talk a little bit about the game sequence here, right? So it kind of goes like this. You start the game, and then you can click on the attack button. The attack button increases a little bit the blue bar of mana on the top. Then we update the character animation to be attacking. We decrease the life of the enemy. We check if one of the characters has won the game, and if not, we trigger the enemy attack. After that, after the blue bar of mana is completely full, we can use the special attack. And once one of the characters has died, we display this dialogue motto with either you won or you lost, and a button to start new game. So in our app.vue file, we have this data object with two objects, the player and the enemy, and both of them have all the information that we need for the animation that we are going to play, the image path, and also the health that starts at 100 for both of them. The player has a mana, and the enemy doesn't, and we also have a game is running that it's by default set to false, and an animation delay that we are going to use later on that is 300. We have a couple of methods that basically just play around with those variables, things like update animation, start game, attack, and etc. And in our template in the app.vue file, I'm not sure that you guys are familiar with the bug syntax, but it's a really short syntax for writing HTML. The reason why I chose to use bug instead of regular HTML is just because it's a shorter syntax, so it's easier to see on the slides. Basically, the indentation defines what element is inside of the other element. So in the app.vue file, on the template section, we have two status bar components in the top, one for the player and one for the enemy. These status bar components are the ones that have the life bar and also the mana bar for our players. So the only difference between them is the object that they receive via props, and the has mana that for our character is set to true, and for the enemy is set to false. We then have an environment component with the slot in which we render the two character components. They also receive some information via props, in this case the character name and the animation that it should play. And then we have the actual controls for the game. So once we start the game, we display these controls for the game, and on the attack button we have an attack method bound to it at click. So the attack method itself calls the increase mana method, which is going to check if the player mana is still under 100, and if it is, it's going to it's going to increase it by 25. Then we have the update animation method, which basically receives as params character, an after animation, and a current animation. So what's happening here is that it's immediately going to change on the character object the animation that it should play, which is basically just a string with the name of the animation. And then we have this set timeout that after the animation delay that we had previously defined is going to update the animation again to something else, like it's going to be attacking, and then it's going to be back to idle. After that, we are just using this calculate damage method, which basically just generates a random number between a minimum and a maximum, and we are applying this damage to the enemy health. Yeah. After that, we check if the game is over, basically just checking if the health of one of the characters is equal or under 0, and if it is, we update the animation to be dying and then dead. And then we display the dialog modal with the result of the battle and the button to start the new game. So in our environment.vue file, there's a couple of interesting things going on here. We have this ship and then some clouds in the background and little ocean waves. And to see how exactly we are doing that, basically this is the file, the Vue file, and we have everything inside of this background div with a class background. It's just a simple div, position relative, and 100% of width and height. But this is important because this allows us to position every child element inside of it with position absolute. We then have a list with the class clouds. And we are basically just looping, counting from 1 to 10, so that we can render 10 clouds on the screen. And if you're using something like Sass, you can actually also create a for loop in your style and make small adjustments to each one of the clouds. This is nice because it allows us to create this kind of parallax effect. So for the animation duration, for instance, inside of the for loop, we are multiplying it by 15. So this means that the first cloud in the list is going to be moving faster than the last cloud in the list, which is nice because if you think about it, when you're, for example, in a car and you look out of the window, the objects that are closer to your car seem to be moving faster than the ones that are farther away. And to create this kind of depth in the scene is really simple. You just have to play around multiplying the index of that element with some number to achieve the effect that you want. So we're doing this for the animation array, for the size of the clouds, and for the opacity of the clouds. And the last thing here is that we have this CSS animation, keyframe animation for the horizontal scroll. That is basically just scrolling the image with the cloud from one side to the screen to the other. We are applying the same technique in the ocean waves that are behind the ship. And for this wave that is in front of the ship, we have a similar technique, but instead of only making it scroll across the page, we actually have a transform translate that is pushing the whole div up a bit, the size a bit, and rotating it a bit, so that we have this sort of wave-like movement going on. The character.vue file is also interesting because it's super simple. It's basically just one div that has a character class attached to it, and then it has this inline style. The inline style is actually a computed property that basically sets a background image based on the image path from the character name that we receive via props, and also the animation name that we are currently updating depending on what's going on in the game. If we look at the actual image for our characters, it's basically sprite animations, right? So we have this really big image with a transparent background. In this case, a background size of 5,345 pixels. And then each one of the rows in this image is going to be a different animation with 10 steps. So for example, the idle animation is going to be the first line, and then we have the attack animation, and then the special attack. And the only difference between them is going to be the original background position and the final background position. That is exactly the same name that matches the strings that we are using on the update animation method in the game. So if we apply just the background scroll, we would have something like this, right? Which is not exactly what we want. So the only thing that is missing there is the animation timing function to make it play like an actual movie. So in this case, as mentioned before, we have 10 steps for each one of the animation rows. So when we say that the character animation timing function is 10 steps, it's going to play like a movie. And then we set the animation duration to 0.8 seconds, and the animation iteration count to infinite so that it never stops playing. That enemy class there is just flipping the enemy around so that one character can face the other. This is interesting because we could reuse the same component to render any kind of character that we want. Then we have this transition tag that comes with Vue. And it's actually really nice because it allows us to create transition animations for elements that are being inserted and removed from the DOM. So in this case, I have a transition named bounce. And Vue has, by default, all of these events, let's put it that way, that you can attach CSS classes automatically to it or use JavaScript hooks to animate some component. Yeah, so here we have a transition with the name bounce, and then I have this bounce enter active and bounce leave active classes that I'm using for this specific transition tag. And both of them have this jump keyframe animation, which is creating this effect that the whole div that contains a button goes up a bit and then hides under the screen. It's basically using, again, translates and transforms to achieve that. Okay, so the game sequence again. We can attack, and then when we attack, we increase the blue bar of mana. Once that's full, we can use a special attack, and we keep attacking until one of the characters has died. Once one of the characters has died, we display the animation, we display the dialogue modal with the result of the battle and the button to start a new game. Okay, enough about the game. Let's talk about some real-life examples now and how you can use similar techniques in your applications. One thing before I forgot. The examples that I'm going to show now are also on GitHub, on the Vue Animations repo under my GitHub, so you can have a look at them afterwards. So more on the transition tag. If you're using something like Vue Router, you can actually make transitions between the routes in your application. So for example here, you can see that the URL is actually changing, so I'm changing from one route to the other. And we also have a small animation for the active item in the menu. And to achieve that is super simple. You just have to use the transition tag the same way that we did for the controls in the game, but you put the router view inside of it. And yeah, on this case, it's just a fade transition between one route and the other, but you could do as fancy as you want. And for the menu items, the Vue Router actually allows you to use custom CSS classes for your active items in the menu. So in this case, I have a menu item class that has a before pseudo element, which is basically just content empty with transparent background and 0% of width. And when it is active, I grow the width to 100% so that we actually have the animation of the line appearing. And we can do the same thing for nested routes. And the cool thing that you can do is decide on what animation to use when you're transitioning to the next route, depending on what route you're currently on and what route you're going to. So on this case, I have a nested route. It's a simple example, so it's just numbers of children. But if you look at the JavaScript section here, we have the transition tag, but the transition name is going to be dynamic depending on what route you're going to. So we are using the before route update navigation guard from the Vue Router to actually change the name of the transition that we're going to use to be either slide down or slide up. And the slide down and slide up are kind of similar again. Again, just translates, but one is going to translate 300 pixels, and the other one is going to translate minus 300 pixels. Since we talked about the transition tag for adding and removing elements from the DOM, we also can talk about group transitions. So in this case, I'm not removing anything or adding anything, even though I could, but I'm actually creating transitions for shuffling the items on the list around. And to do that, we use a similar technique, but instead of being a transition tag, it is actually a transition group tag. And instead of passing a name for that transition, I'm going to apply the transition to the class of the children inside of this transition group tag. It's important that they have to be keyed, and then you can just apply any transition that you want to it. So in this case, it's basically a transform that lasts for 1 second, and I have a cubic Bezier timing function applied to it. Okay, so that's the same way that we did with the character component, that we're using the same component to render our character and also the enemy. We can wrap the animations that we want to use in different parts of our application inside of components. So for example, you could have a floating button menu component. And basically what's going on here is that we have this toggle menu method that is going to change the value of the menu is visible variable from false to true or the other way around. And we are using this variable to display the overlay under the menu and to actually change the positions of the menus to be open or closed. So we have this v4 that loops through this child buttons array, and every object inside of this array has all the information that we need to render the buttons. So we have a label, we have a link, and we have an icon. And this is cool because we don't actually have to know about how many items we are going to have in this menu. We can just reuse this component, and it's going to take care of all the animations for us. So here we have a style that is actually calling a method called calculateButtonStyle. And this method is going to return an object with the new position for each one of the items. And again, using the index of that item in the list to calculate the distance. The same way that we were doing with the clouds on the game, that we were multiplying some number with the index of the clouds to make it have different animation durations and this kind of thing. Here we are using the index to calculate the bottom property in the CSS, the transition delay, and we are using the menu is visible variable to calculate the transform as well, so they can decrease the size a little bit when they are hidden behind the main button. So it might sound a bit confusing, but remember that this method is actually being called for each one of the buttons on the component. So for the first button is going to be the bottom property, 1.3 times 50 equals 65, and then for the second one, 2.3 times 50, 115. And then we can guarantee that the next button is always going to have a 50 pixels distance from the previous one. So yeah, this is a really, really long menu, but I just wanted to show how you can create this staggered animation effect because we are using the index of the buttons to actually calculate the transition delay and also the position automatically based on the index that we have. Okay, so another example, we could have this collapsible content component, right? It's basically an accordion behavior that you can show or hide some content in the application. And once again, we have a variable. In this case, it's a show variable that we toggle true or false to either hide or display the content. And basically, we are using this variable to attach new classes to the hidden content, to the toggle button, and also to choose which text to actually display in the button. So in the CSS here, you can see that we actually have a little animation that transforms from a plus to a minus when we click on the button. And that's being done through pseudo elements before and after. Both of them are basically just empty content again, and 10 pixels of width and 2 pixels of height, so that they are this little line. And then, when we have a minus, both of them are stacked on top of each other. When we have a plus, they rotate around and become a plus. A little bit of data visualization now. So on this example, we have a simple line chart that was built with SVG, and we are using the GreenSock animation library to actually animate the numbers between one data set and the new one. So if we notice, we actually have this computed property called lines, which is an array with all the core x, y, and y coordinates for the data points that we have. So the lines array in which we're looping in our template is actually giving us the x and y coordinates based on its index and the actual data points. So the horizontal distance is always going to be 10 pixels from the last one. So you can think that this chart was actually built on top of a grid of 10 by 10 squares. And we are creating these coordinates using the index again, so that one data point is 10 pixels apart from the previous one, so this for the horizontal axis, and for the vertical axis is actually going to be the data point itself. So as this is just an example, I have this method, generate points, that is just creating some random numbers for us to play around. But when you click on the new set method, we are actually saving the current data points in a previous points variable, and we are generating the new points and saving them into a new points variable. This allows us to use the tween light from GreenSock to animate each one of the numbers in the array until it reaches a new one. And I'm not doing this in a linear way because I want this bounce effect to happen, so I'm using an elastic timing function here. Again, I know that it might sound a bit confusing, so this is what happens when we console log every change of the number in the chart. So the number that we are console logging here is the first one in the array that starts with 25. It's the same number that is being rendered on the first dot in the chart. And if we look at the numbers, you can see that the 25 doesn't go linearly to 40. It actually goes up to 46, and then it decreases it to 40 again to cause this bounce animation effect. And another cool thing that we can do is integrate it with canvas. So on this example, we have some bubbles bouncing off the edges of the screen. And once we have the mouse close to one of the bubbles, we increase their size and we change their color. And to do this kind of thing, we just need the canvas tag, and then we have this update mouse position attached to the mouse move, to the mouse move on the canvas. And this method, basically what it does is that it updates the X and Y coordinates of the mouse so that we can use it later on. This mouse is an object that lives in our data object of the component. And it's important to notice that we also have an empty circles array that we are going to fill soon. Okay, so in order to create all of these circles on the canvas, we are going to use the mounted lifecycle hook. And so the first thing that we do is that we access the canvas that we have in our template through the refs. And then we set it full screen by making the canvas the same width and height of the window. And then we are going to loop through a number of circles that we are receiving via props. So here I'm going to create 50 circles. And I'm also receiving a main color via props, which is this greenish, bluish tone that you can see on the screen. Yeah, so inside the loop, I'm actually going to create a random number for the radius. Again, like that calculate damage method that we had on the game, is just a random number between a minimum and a maximum. So I'm going to save this number to a radius variable, and then I'm going to multiply it by 2 to have the diameter for that circle. And then, okay, before we talk about the constructor here, this circle object that we are using to create each one of these bubbles is actually using the random number method again. But it's important to notice that for the x coordinate, the minimum is going to be the diameter, and the maximum is going to be the width of the window minus the diameter. And the same thing goes for the height. The minimum is the diameter, and the maximum is the height of the screen minus the diameter, because I don't want to create bubbles that are outside of the screen. And then we have also the dx and dy, which is basically the velocity of each one of these bubbles. And random numbers again, because I don't want them all to move at the same pace. So negative numbers are going to be moving backwards, and positive numbers are going to be moving forward. And the color is basically pointing to the main color that we receive via props. So then we are going to use this create circle constructor that receives the circle object that we just created. It receives the canvas context, which is basically pointing to the context of the canvas that we can access by refs. And it's also receiving the mouse object that we keep updating every time that we use the mouse inside of the canvas area. So this is the constructor. And the constructor will return an object that has all the information that we just passed down. But it's also going to include a draw method, which is basically going to draw the circle. And it's important to notice here that inside of the fill style of the circle, we are actually attaching the circle radius to the color of the circle. So that's why when we increase the size of the circle, it becomes more blue and less green, because we're actually rotating the initial color based on how big our circle is. We then have this update method that is basically, the first 2 checks are just to check if the circles have hit one of the edges of the screen. So if it did, I'm going to reverse the velocity so that instead of keep moving forward forever, it's going to move back. Yes, so then we have this interact with mouse method. Yeah, the interact with mouse method is basically going to check to see if the current circle is close around the 50 pixels that are around the mouse. And if it is going to increase the radius of that circle by 1 until it reaches the maximum radius that we can define. The maximum radius on this specific case here is 3 times the original size of that circle. So if the circle is close to the mouse, we increase it, and if it is not, we decrease it by 1. But once again, we don't want to kill the circle, so we reduce it until it reaches the minimum radius. And the minimum radius is going to be the original radius that that circle was created with. Yeah, so after we created all the circles and we have this array with this bunch of circles that we can access, we actually have this animate method. And the animate method is the method that actually makes it all happen. So the animate method first calls a request animation frame, passing itself as a callback to be invoked before the next repaint. We then clear the whole canvas, and we call the update method of each one of the circles in our array. So the update method of each circle is the one that's going to check if it had hit one of the edges, or if it is close to the mouse, or if it is not close to the mouse. Yeah, okay. So once again, we have all of these bubbles. They never go off the screen, and if they are close to the mouse, we increase them by size. When we do that, because the fill style of that specific circle is attached to the radius, we actually change the color of it, and when we move the mouse away from it, we reduce the size again until it reaches the original size of that circle. And that's it, folks. I hope you enjoyed the presentation.